In the previous lecture, we discussed about K-map, how to solve the K-map with the help of sum of the product and the product of some form. But before we further extend our analysis in the K-map, we should know what are the different terms that are associated with the K-map, and that is important to understand. Okay, so as of now, we are able to understand. Suppose I have any function. Let us consider one function. And if that function is something like f is equal to a b bar c plus ab plus bc bar, let us assume this is the function. Okay, now if you closely see this expression, we have three different variables: variable a, variable b, and variable c. Okay, but in the first term, which we can see here, in the first term, we have all the variables that are present. In the second term and the third term, all the variables are not present. In the second term, C is missing, and in the third term, A is missing. Okay, so in this particular lecture, we are going to discuss what are the different implicants in the K-map, and that is what we will discuss here. We know that if you talk about the sum of the product or product of some form, so simply suppose I have any expression something like that: f is equal to ab plus ac, ab plus ab bar. Let us assume ab plus ab bar I have. So now if you see here in this second function, I have a two variable, and in the both the terms, both the product term, both the variables are present. Okay, so if all the variables in any of the min term or any of the max term is present, then we can call it the min term or the max term. So we can call them min term or max term only if all the variables are present. Okay, so see here in the second equation or the second function, both the terms are the min terms. Okay, we can call them both the terms, these are the min terms. But if you see the first expression, in the first expression, here I have a b bar c, because in the first expression we have three different variables. Okay, and in the first term we have all the variables present, but in the second and the third term all the variables are not present. So if all the variables are present in the first term, we can call a b bar c, this is the min term. Okay, this is the min term, whereas ab plus bc bar and including a b bar c, we call all them the implicant. Okay, so these all are the implicants. Let me change the color so that will make you some sense. Okay. Okay, so if you see the second expression, we have both are min term. So in the second expression we have, let me properly write it so that you will be able to understand. Here this term we can call, this term is the min term. Okay, and this term and this term, we call it the implicant. Okay, so the min term means if all the variables are present. Similarly, we can also explain for the max term. Like if I have any expression something like f is equal to a plus b plus c bar into a plus b. Okay, so this particular term is the max term, and in this function we have two implicants. Okay, so this is how we decide how many implicants we have. All the min terms or max terms are implicants, but all the implicants are not necessary that they are min term or the max term. Okay, so vice versa is not true. So this is how we can see from this particular expression, and similarly we can also understand from the SOP or POS from both. Okay, so let us try to see how we can consider the things. Okay, so the first thing is like, so let us assume I have a three variable K-map, and if this three variable K-map is given something like this: a b c 0 1 0 0 0 1 1 1 and 1 0. Okay, so the first term that we need to understand here is the min term or the max term. So we know that what min term and max term is. So min term and max term means if in any of the function, if all the variables are present in that term, then we can call them the min term or the max term. Okay, so in this example, whatever we can see, we have written over here, the first term we can call it the min term. Okay, now second term is the implicants. I just told you, like number of like if I'm considering the SOP form. Okay, see, if I'm considering the SOP form, so in the SOP form, number of product term. Okay, so number of product terms are we can call them the implicant. Okay, and similarly, if I am considering the POS form, so in the POS form, number of sum terms. Okay, so we can call them the implicant. Okay, so these are the implicants. So this is all about the implicant. Next, one very important terminology regarding implicant is, okay, prime implicant. What is that prime implicant? Okay, so if I talk about the prime implicant, so prime implicant means a group of square or a rectangle that made up of bunch of adjacent min term or the max terms. Okay, that is allowed in any of the K maps. Suppose I have something like that. Let me take some example. Suppose I have 1 1 1 and 1. Okay, so this, let us assume I have a K map which is filled like this. Okay, 1 1 1 1. So how many pairs I can make? How many possibilities of pair we can make? So the first possibility, let us see here. I can make the pair of these two 1. I can make the pair of these two 1. And there is one more possibility. I can make the pair of these two 1 as well. This is also possible. I can make, because this one and this one, like green color, whatever I have made the pair, this is also one of the possible pair. Okay, so the prime implicant says that, so the total number of possible pairs that we can create in any of the K map is known as the prime implicant. So in this example, if we see, we have 4 implicants. Okay, we have 4 implicants because I have 4 number of ones. But if we talk about the prime implicant, we have 3 prime implicants. So this is what the prime implicants means. So the number of prime implicant in this case is 3. The next term is, next implicant is the essential prime implicant. What is this essential prime implicant? If you see here, the number of pairs, those are possible to complete or to solve any of the K map, or those are necessary to solve any of the K map, is called the essential prime implicant. See here, if I have this example, in the same example, if I do not consider this blue part, this green part, so still all the ones are paired. Okay, so this green pairing is not required. This green pairing is not required. In this case, whatever the pair I have made in the blue color, these both are mandatory. Suppose, let us assume I have removed this one. So it is not possible, even though I have made one pair over here. So I'm not able to make the pair of all the ones. All the ones are not in the group. Okay, so I need to make one more pair over here. But if you see, this pair is mandatory, and if I try to remove this one, still all the ones are considered. Okay, so how we decide which are the prime implicant and which are the essential prime implicant? So essential prime implicants means the number of pairs, those are sufficient to make a pair or to consider all the implicants in a K map. Okay, so if you see here, the essential prime implicants are 2. 2 essential prime implicants are here. Okay, so this is what the important is. Next prime implicant, next terminology is the redundant prime implicant. Redundant prime implicants means the prime implicant for which each of these min term is covered by some of the essential prime implicant. If you see here, one pair is also possible. I just told you this pair is possible. We can make the pair of these two, one which is in the green color. But one of the term, this term is covered with this one, this of the essential prime implicant, and this term is covered with this one. Okay, so if each of its min term, or if each of its implicant is covered with any of the essential prime implicant, so those kind of implicants are known as redundant prime implicant. Okay, so the redundant prime implicants means the group pairs of, like the pair on which any of the variables that are covered with any of the essential prime implicants. Okay, so this is how we decide the redundant prime implicant. So the green portion, if we see here, this one portion, redundant means which is not required. Okay, the pair which is not needed, that will not appear in the final expression. If I solve it, if I remove this green part, that will not affect the operation of this function. Okay, so we call them the redundant prime implicant. Okay, so in this example, we have one redundant prime implicant. So important thing is the redundant prime implicant never appear in the final solution, but the essential prime implicant always appear in the final solution. Okay, so this is some of the important term. One more term that we need to consider here is the selective or the non-essential prime implicants. Okay, selective or non-essential prime implicant. What is the selective and non-essential prime implicant? Basically, the prime implicants for which are neither essential nor redundant. These kind of prime implicants are called selective prime implicants. Okay, so this kind of the selective prime implicants, we can also call them the non-essential prime implicants. So the important thing is, I will give you the example. Pi prime implicant is blue and gray part, essential prime implicant is only blue part, and redundant prime implicant is only green part. Perfect, correct, absolutely correct. Okay, so the green circle and the blue circle, all, if you consider all the possible number of pairs, those are the prime implicants. The minimum pairs that can complete all the implicants, those are the essential prime implicants. So the blue circles or blue pairs are the essential prime implicants, and the implicants which are not required, like all the implicants are covered with other essential prime implicants, so we can call them the redundant prime implicants. Like this green one is not required, but yes, still we can make the pair. This pair is also possible. Okay, so we need to find the possible pair, but all the implicants are already covered, so we can call them the redundant prime implicant. The next kind of implicant is the selective or non-essential prime implicant. I just told you the selective prime implicants are those implicants which are neither essential nor redundant. Okay, so these kind of prime implicants are also called non-essential prime implicant. In this example, there is no selective or non-essential prime implicant, but I need to consider one more example to explain that one. One very important thing is, if we differentiate essential, redundant, and selective one, so the essential prime implicant means all the prime implicants which are essential, they will appear in the final result, final expression. Redundant prime implicant, they will never be appear in the final expression, whereas the selective or non-essential, they may appear or they may not appear. So both are possible. Okay, so this is how they are different. So let us to explain in this example whatever we have considered over here. In this example, selective prime implicants are 0. There is no selective prime implicants. Okay, but to explain this selective prime implicants, let us consider one example, and I will tell you what are the selective prime implicants. So let us assume I have a 3 variable A, B, and C. Let us consider the same example with some addition. So 0, 0, 0, 1, 1, 1, and 1, 0. Okay, now if I try to make the ones, so 1, 1, 1, 1, and let us add one more 1 over here. Okay, now let us try to make the pair. Okay, how many pairs are possible? Okay, so let us try to see. One possible pair is this one. Second possible pair is this one. Okay, third possible pair is this one. Now these three are sufficient to cover this one. Okay, these three are sufficient to cover this one. Now if you see here, we have the possibility like we can make one more pair that we can form over here. So this is one of the possibility. Now let us make one more possibility. Now your doubt will be clear. Okay, so let me consider another pair. ABC and 0 1 0 0 0 1 1 1 0. Okay, now let us try to write the same thing 1 1 1 1 and 1. Now if I try to make the pair, one pair that I can make over here, the second pair that I can make over here, and the third pair that I can make over here, and the fourth pair, if you see here, I can make over here as well. Okay, now if you see this particular figure, first one, in the first figure we see like the blue part which we have covered, those are the essential one. Okay, because to cover all the ones whatever we have, we need at least three number of the pairing these that are given in the blue color. The similarly, there is one more possibility to cover all the ones. The second one, if you see the second one, I have also three possible pairs that is required to cover all the ones. Okay, in the first figure I have a green color pair which is the redundant one, and in the second pair I have another one which becomes the redundant one. Okay, now if you see here, if we try to combine both the things, if we try to combine both the things like A, B, C, so I have a two pair which can be the essential in one case and becomes the redundant in another case. Now let us see here. Let me change the color so that I can explain you. If you see this one, in this one, this particular pair is the redundant prime implicant. Okay, and this particular pair is the essential prime implicant. But if you see the second case, in the second case, this pair becomes the essential prime implicant, and the second pair which we have, this becomes the redundant prime implicant. Okay, so the pair which can be redundant prime implicant or the essential prime implicant in the two different pairing possibilities, so those kind of pairs are called selective or non-essential prime implicant. So if you see here in the first figure, like if you see in the detail of this figure, so let me draw the one more K map to make the clear your doubt. So here are the possibilities. Like here I have A, B, C, 0, 1, 0, 0, 0, 1, 1, 1, and 1, 0, and 1, 1, 1, 1, and 1. So this is the pair. So if you see this pair and this pair is mandatory. Okay, these two pairs are mandatory, but rest I can add one pair either in this direction. I can make either this one or I can make this one. So these both are possible. So these are not essential. So this pair and this pair is the essential one. So these two are the essential prime implicant, and I have, like, if I'm considering this as an essential, so this will become the redundant one. Okay, and so the important point of consideration over here is the pair, this one and this one, is called selective prime implicant. Okay, So these two pairs are the selective prime implicant because these are not essential. Either I can use the first pair or the second pair. Okay, so these two are the selective prime implicants or the non-essential prime implicant. So let me explain these two things. The prime implicants I just told you. Essential prime implicant I just told you. If you see this diagram, in this diagram we have two pair which are essential. This pair and this pair. Okay. Now I have one. This one is left, which is unpaired. So either I can make the pair with this one, or I can make the pair with this one. So because these two are the possible way to make the pair of a pair with this one, so we can call them, these two are the selective prime implicants. Now, if I am making the pair with this one, okay, if I'm making the pair with this one, so this portion will become the redundant prime implicant, and if I am making the pair with this one, so this circle will become the redundant prime implicant. So if you see these two cases, I have made the pair with this one. Okay, if I have made pair with this one, so this will become the redundant prime implicant. But if I am making the pair with this one, so this will become the redundant prime implicant. Okay, but whereas in the same K-map, these two pairs are the selective prime implicants. So like any of the prime implicant can be, I just told you, the selective prime implicants can be they can be covered in the to make the complete pair, or they are not mandatory. So they are neither essential nor redundant. Okay, so those kind of implicants we can call them the selective one. Your doubt is clear or not? You got the point? Who asked this question?
Sir, I was asking that if there are essential ones are already present, then we say that other which is left out can be the redundant one.
Yes,
So
yes.
in that one, all the ones are covered with already covered actually.
Where already covered in which example? Here in this one? No, I think your doubt was like, what is the definition of redundant prime implicant? I did not get your question actually. Can you repeat your question again? Hello? He left. I don't know who was asking. Can anyone tell me who was asking? Adit, you was?
No, sir, Arpit was asking.
Arpit was asking. So he's not here? Arpit Tiwari. Okay. So Arpit, your doubt is clear or not? Let me know. Otherwise, I will explain it again. He left? He is not here. Huh? I don't know. Okay, fine. So if he'll join back, then I will explain it again. So let me repeat it again. What is the meaning of this one? As I understand his question, let me tell you again. So the first thing, like we know the prime implicants. Okay, what are the prime implicants? All the ones which are here, those are the prime implicants. We know like like how many pairs we can make. Those are the prime implicants. Implicants are how many ones we have. These are the implicants. Essential prime implicants, the pairs which are required or which are essential in any of the K-map. Because if you see here in this K-map, these blue portions are essential. Without these two pairs, you cannot make the pair of all the ones. So these two are the essential one. Okay, these two are the essential. Okay, so he joined back. Let me ask the question again. I think Arpit, can you repeat your question again?
Yes, sir. I just got disconnected.
Okay, so what was your doubt, please? Yeah.
So when we say that something is SPI, then it can neither be EPI or RPI. Then how can we find number of RPI or EPI? It is covering them or it is just SPI then? Like the question is how many RPIs are in the K-map given below. So we will count the SPIs also in that.
Yeah, so I got now I got your question. So please wait, I'm taking one more example and then your doubt will be clear. Okay, so you will get it. So I understand what you're asking. Like, so you're saying like if I have a I have considered the selective or non-essential prime implicant. So here in this case, I have a 2 non-essential prime implicant and I have a 2 essential prime implicants. So how many redundant prime implicants are there? Is it?
Yes, sir.
You were asking. Okay, so please wait. I will consider one more example and then your doubt will be clear. Okay. So I think the definition of all the implicants are clear. Is there any doubt on the definition? Any of the definition? If you have any doubt on the definition, you can ask the question. Anyone? Okay. So I'm hoping there is no doubt on the definition side. So let us consider one example. Okay. So suppose I have a SOP form that has been given, and I need to find the number of implicants, number of prime implicant, essential prime implicant, RPI and SPI. Okay, so let us try to make it. Okay, and then your doubt will be definitely clear. First, suppose the terms which are given like 0. So here I need to keep 1, 1, 5, 7. Yeah, let me keep it in the different color so that will help you. Okay. So 1, 1, 1, 1, 10 is 1, 14 is 1, and the 15 is 1. Okay, so these are all ones based on the function is given, right? Now let us try to make the pairs. Okay, so the first pair which is possible is this one. Okay, now please tell me, like, can I cover this one with any other pair than this one? Is it possible? Can I cover this one with other ones?
No, sir.
It is not possible, right? So it is mandatory to make the pair of this first one, which is at 0, to make the pair with 1. So this is the essential prime implicant. Okay, so this is essential one. Okay, now if you see here, can you tell me what is the possibility to make the pair of this one which is at location 10? How many ones are there that can be used to make the pair with this one which is at 10?
So only one, which is
Only one,
position
right?
number 14.
So we need to make the pair with 14 only, right? So this is the essential one. So this is essential. I cannot make the pair of this 10 with others. I have only option that I can make the pair with 14. So these two pair are the essential one. Now, if you see here, what are the other possibilities that I can consider? Either I can consider, I can make this pair and I can make this pair. This is one of the possibility. Okay. Second possibility could be, yeah, so let me consider the second possibility as well. I need to make so that you will be able to understand what I'm teaching. So, okay. So let us consider I have 1, 1, 1, 1, 1, 1, and 1. So we are now clear that I have this one is the essential one and this one is the essential one. Okay, so these are the blue color is essential. Just try to understand. Now, if you see here, I can make like in the first figure or in the first K map, I made pair of this one and this map, and all the ones are covered. Second possibility could be I can make the pair with this one or this one. This is one of the possibility. Third possibility could be I can make the pair of this one with this one and with this one. This is also possible. Fourth possibility could be I can make the pair with this one and with this one. We have already done it, right? And this is one of the possibility. Okay, so there are other possibilities as well. Okay, but those are not mandatory. Those are not essential. So I have only two pair. Those are essential, are this one and the last one. So we have these two essential prime implicants. So let us try to write the first parameter which we have is the number of implicants. How many number of implicants we have? Can anyone tell me? How many implicants we have?
7.
7. Perfect. So we have the 7 implicants. Number of prime implicants. How many number of prime implicants we have? Number of prime implicants.
So 4.
Number of prime implicants are?
4.
What is the definition of number of prime implicants?
So covering all the pairs.
6.
6. Who said this 6? Who is that?
Me. Okay.
Arpit. Okay. 6 is correct answer. See, I just told you the prime implicants means all the possible pairs that we can make in any of the K-map is the prime implicants. So we have the possibility like I can also make the pair this one and this one. This is also possible. Okay. So the total pairs that are possible are 1, 2, 3, 4, 5, and 6. Okay. So the total possibility is like the number of prime implicants are 6 here, not 4. Okay. So let me repeat it again. What is the prime implicant? Prime implicants means all the possible pairs that we can make in any of the K-map is the prime implicant. So here we have 6 prime implicants that are possible. Okay. Number of essential prime implicant we have already seen in this one. Only 2 pairs that are possible and that are the essential one, and those are the 2, number in 2. Okay. If we talk about the number of let me first discuss about the selective prime implicants. How many selective prime implicants we can have? This is really very important question, right? So you will be able to understand. So these 2 are the essential one. Now let us talk about the selective prime implicants. Okay. Now let me make the pair first. Let me make the pair so you will be able to understand. How many selective prime implicants?
Total minus essential one. 4.
4. So selective one, yeah. So like see here, which are those possibilities? Okay. So let me try to consider. This is one of the pair which is possible, and the second pair which is this is possible. Okay. Second possibility could be like I can make pair with this one and I can make pair with this one. Okay. So like these both are I like these 4 possibilities that can give you the selective kind of prime implicant. Okay. They are neither essential nor redundant one. So these 2 and these 2 are the selective prime implicants. So the total possibilities for the selective prime implicants are 4 in any of the K-map. There is no other combination that can be considered as a selective prime implicants. Okay. Now, if you see, if I'm considering these 2 as a selective, so these 2 pairs become the redundant one. This pair and this pair is the redundant. Okay. And if I'm considering this one, so this pair and this pair is the redundant one. Yes, 2 redundant prime implicants are possible, but the total possibilities, like if we see here, like selective prime implicants are 4, and after considering the selective prime implicants, the redundant prime implicants are 2. Yes, Jayant, you are asking like, see, selective prime implicants means what are the how many pairs we have? Those are possible and those are not essential or not redundant one. Okay, so if you see here, if you see the first combination, in first combination, the purple color which I have made, I am considering these 2 are the SPI, and in the second pair, I am also considering the purple one in the SPI. So that these are the 4 way that I can consider these 4 are the selective prime implicants. Okay, so these are the 4 possibilities. But if I'm talking about a redundant one, so redundant will be considered after considering the selective one. Okay, so once we have considered the selective one, now these green portions become the redundant one. So in this figure, in the first one, I have 2 redundant one, and in the second one also I have 2 redundant one. So the redundant prime implicant will be 2. Okay, so this is how we can consider the thing. Do you have any doubt on any of the points? If anyone has any doubt on this, you can ask the question.
So why it is not 4? So redundant one.
Redundant one, because see, the redundant will be considered, because see, the redundant will be considered how many pairs that we can that are not required in any of the K map. See here, because suppose I have let us consider the first one. In the first one, this blue portion is the essential one. This is perfectly fine. Now I have made two purple one. Okay, I have made two purple one to cover all the ones. Okay, so the selective one, like this is a selective one that is required to cover all the ones. Okay, after selective one, how many pairs we can make other than this which are not required? So those are the redundant one. So after considering the selective one, in any of the K map, I need only two. Okay, so that is why it is coming to. So yeah, I think I know what was your reference to ask this question, because we are considering we have the 4 possibility for selective one, so why not the 4 possibility for the redundant one?
Yes,
So
sir.
this was your concern, right?
Yes, sir.
The thing is, because the redundant comes after the selective one, so once we have considered the selective one, then after we can consider the redundant one. Okay, so we cannot say this is the redundant one. Okay, so after considering the selective prime implicants, then we can comment on the redundant one. We cannot say all these are redundant. Suppose if I am saying this is redundant, okay, if this is the redundant, so, but this is not. Okay, so that is why it is coming. Okay, so the redundant will be considered after considering the selective one. Okay, so hope your doubt is clear.
Yes, sir.
Okay, so these are the important thing about the implicants, prime implicant, and other things. Okay, so it is not necessary, like, yeah, let me write the numbering so that you will be able to understand few things more. Let us assume this is the first circle, first pair. Let us assume this is the second pair, this is the third pair, fourth pair, fifth pair, and sixth pair. Okay, so if I'm considering the first K map, okay, in the first K map, the implicants are, yeah, we have the implicant. I have already given. So number of prime implicants, these are the pair 1, pair 2, pair 3, pair 4, and pair 5, and pair 6. So these all are the prime implicant. If we talk about the essential prime implicant, in first figure, the essential prime in first and second essential prime implicant 1 and 6 are the essential prime implicant. If we talk about the selective prime implicant, so the third and fourth, like third and 2, 3, 4, and 5. So 2, 3, 4, and 5 are the selective one, and the redundant prime implicant is either 2, 4 or 3, 5. Okay, so this is the possibilities. In the first figure, in the first K map, 2, 4 is the redundant one, and in the second one, 3, 5 is the redundant one. Okay, so hope doubts are clear. Okay, so this is all about the implicants.